So we can look at examples of this. If I have HCl, that goes to H plus Cl minus. The pKa of that equals -7. So here are the questions that I want to ask you to consider as you pause the video before you come back and listen to how I describe it. How much does HCl want to dissociate? And you don't need numerical answers here. You can say a lot, a little, not at all. And then the next question I have for you is, how much does Cl minus want to take a proton? To form HCl. These are both really important questions in understanding how acids and bases work in organic chemistry. So go ahead and pause, try and see if you can answer, at least in your head, and then come back and we'll talk about it. So the first one, how much does HCl want to dissociate? Well, with a pKa of -7, that means that it dissociates 10 million times for every one molecule that stays together. So I guess you could say a lot, or some kind of large thing there. And really what it is it's a strong acid. And usually when we talk about strong acids, we consider them to be fully dissociated. We'll often say that they're fully dissociated. It's not really true. It's only 10 million times more than it is together. So there are still some molecules of HCl present, but there's 10 million of these for every one of these that's still together. The next question asks you to go a step farther than what we've talked about so far, and it asks, how much does chloride want to take a proton to form HCl? If HCl is a strong acid, and that means that this is favored over here on this side 10 million times to 1, if I take a chloride and I put it in with protons, it really doesn't want to take that proton to reform HCl. So chloride does not want a proton. And so what we'd say about chloride is that chloride is a negligible base. It really doesn't want a proton at all. How much does it not want a proton? 10 million to 1. So 10 million to 1. It'll take one time for every 10 million times it doesn't take one. So this was a strong acid example. Let's look at a weaker acid example. Alright, so in our weak acid example, we have acetic acid that dissociates to give proton, and then this is called acetate. The pKa of this is 4.8. Alright, so let's look at the same two questions that we had before. How much does acetic acid want to dissociate? And then how much does acetate want to take a proton back? So pause again and try to answer it for yourself, and then come back and we'll discuss. Okay, here with a pKa of 4.8, you can estimate if you want. I mean, I'll give you the Ka. The Ka of that, you can calculate it, is 1.6 times 10 to the minus 4. But really, if you look at it, I'm happy with you saying, well, it's somewhere between 10 to the minus 4 to 10 to the minus 5. So it's somewhere in that range. That's good enough for understanding what's happening. So if you're saying how much does HCl want to dissociate, well, it stays together about 10,000 times for every one time it separates. If I'm looking at a solution, it's mostly going to be acetic acid. Then if I look at the same kind of question here, how much does acetate want to take a proton to form acetic acid? Well, it kind of wants to take one about 10,000 times more than it doesn't want to take one. So this we would consider a weak acid. And this acetate we would still consider a weak base. A preference of about 10,000 times is still a weak base. So we have a weak acid, weak base combination. The first one, we had a strong acid here in HCl, which gave us a negligible base in chloride. Here we have a weak acid, weak base combination. So we have a third one to look at, and that's what happens when we have a strong base. All right, so for this example, we can look at methane. Methane goes to H plus and CH3 minus. The pKa of methane is roughly 50. Okay, so we want to figure out what kind of an acid, how we would call this as an acid. So the same two questions. How much does it want to dissociate? And how much does CH3 minus want to take a proton? Okay, pause again, try to figure out what you think, and then come back and we'll talk about it. Okay, with a pKa of 50, that means that the Ka is somewhere on the order of 10 to the minus 50. We don't even have words to describe what minus 50 is. We don't put a name to that kind of number. It's just so huge. So what that means is that nearly every single one of these is still together. There are almost none of these that are apart. So how much does it want to dissociate? Not at all. In fact, you wouldn't even be able to measure it. If you put it into some kind of a spectrometer that you could look at molecules, you won't see any of them that are apart because there's 10 to the 50 that are together for every one that's separated. So how much does it want to dissociate? Not at all. So what kind of acid is that? We'd call that a negligible acid. It really doesn't act like an acid at all. A strong base, negligible acid. So now you have the reverse question, and that is, how much does CH3 minus want to take a proton? Well, if you have CH3 minus, it wants to take one 10 to the 50 times for every time it wouldn't want to take one. It wants one really, really bad. This is an extremely strong base. In fact, these kind of bases are so strong that you have to be very careful in how you work with them, because they'll catch fire in air. They react so fast, so easily, even just with water vapor and air, that that they're very hard to work with at times because they'll react with anything.